So this is 7th grade, 4-3, page 209. And we're looking at the first example. Actually, I'm not going to spend a lot of time on these examples. I got to zoom this out a little bit. Because really this is all about combining like terms. But now the terms have fractions and decimals. So you can look at the first example if you want. The try it, I already had you guys copy down the answers for that. So it says simplify the expression -6 minus 6f plus 7 minus 3f minus 9. Well, what are the like terms here? It should be pretty obvious. The like terms are the -6f and a -3f. And if we combine those together, what do we have? We have a -9f. Now we have a -6 plus 7. Well, just -6 plus 7, what's that going to be? -1. Well, what's -1 plus or adding a -9 or subtracting 9, however you want to look at it? It's going to be a -8. Oh, wait a second. I heard somebody say -1. Actually, it's going to be 1. And then 1 plus a -9 would be a -8. Okay. Example 2, we'll let you look at that if you want to, but let's look at the two try-its together here. It says simplify each expression. Get myself a sticky note here so I don't run out of room. So let's look at the first one here. What are some of the like terms? We have an m here, and then an m here, and an m here. So there's 3 m's, and then a -30 and a +45. Well, what's a -30 plus 45? 15. Okay, so that's done. So now we have a 59.95 m, and we're adding a 7.95 m, and we're adding a 9.49 m. Well, I guess I could just line everything up. 59, I'm not subtracting anything, 0.95. And then we have a 7.95. Notice how I'm lining up the decimals. When we're adding and subtracting, that matters. And then we're adding another 9.49. 9.49. What's 5 and 5? 10 plus 9 is? Put down the 9, carry the 1. So 9 and 9 is? Plus 1 is? 19. What's 19 plus 4? 3. Decimal goes straight down. It was a 2. So again, I look at numbers and I try to add the easiest ones in my head. I don't always go just straight down. So I'm looking at this row here with a little 2 on the top. What's 9 and 9?
18.
What's 18 plus 2?
11.
11? What?
20.
So 9 and 9 is 18 plus 2 is 20. What's 20 plus 7?
7.
And what's 5 plus 2?
7.
There we go. Oh, I didn't need a decimal there. So 77.39 m. I heard somebody say it. 77.39 m plus, what did we say? 15. Okay. Let's look at this one. Zoom in a little bit here. So we have a -0.5p plus, I got to move that down a little bit, it's kind of in the way, plus 1/2 p. What is that? 0. 1/2 and 0.5 is the same thing. One's positive, one's negative. So it's 0. So now what? Now I have a -2.75. That's all by itself. It doesn't have a p. And then what? 2/3 p. So what's my answer? Yeah. Or you could just write it like that. Either way. If you put the 2/3 p first, then you would just be subtracting 2.75.
But if you want, you would just do negative.
Yeah, because
Yes, exactly.
adding,
Yep.
like, 1 plus negative
Right.
is the same as 1.
Okay. Questions on that, anybody? No? All right, we already looked at example 3 and the try it down below. Gave you those answers. It's much the same thing. And we, for those that are absent, we already wrote down 1, 2, and 3. Come on, focus. It's still not focused. Huh, what's up with that? One more time. Come on, focus. Focus. That's better. How are properties of operations used to simplify expressions? Well, you can reorder the terms, you can group them and combine like terms. That's number 1. Number 2 and 3, I should have circled those because I want you to do those also, and I gave you the answers to them. Explain why constant terms expressed as different rational numbers can be combined. Well, it's the same number, they're just in a different form. For example, like I said earlier, 1/2 x is the same as 0.5x. And then number 3, how do you know when an expression is in its simplest form? Well, when there isn't any more like terms that you can combine. Number 4, circle that one. And number 5, and number 6. Next page, page 213. 7, 8, 9, and 10. Looks like I got another one that I was going to do here. Get another sticky note. Okay, I got too many pens here. Let's look at number 10. Zoom in a little bit. All right. It says simplify each expression. So there's a 12 plus a negative 4, and then a 5th j minus 4/5 j plus 5. So we can deal with the negative 2/5 j plus or minus 4/5 j. What's that going to be?
Negative 2/5 j.
No. What do you guys think? Yeah.
Negative 1 1/5.
Right. Or you could just leave it as an improper fraction. So it's going to be, when the denominator is the same, they're both 5. All you have to do is add the top. 2 and 4 is what? 6. So we'd have a negative 6/5 j.
Yeah, but it's subtracting.
Right. So what's the rule for subtracting?
You would take it away.
Well, let's back up a little bit here. Let's do something really simple. So if I had a negative 3 subtracting 2, what is that? 5. It's what? Well, not 5, but it's what? A negative 5. Because the rule that I taught you guys last year, if I recall, and I've talked about it this year too, is that when you have subtraction, you would keep this part the same, change it to addition, and change the sign of the number that follows. And you get the same answer. Okay? Remember that. Whenever you have subtraction, sometimes you need to think about it in the terms of, well, I'm actually adding a negative number. Negative 3 plus a negative 2 is negative 5. Well, you also know that negative 3 minus 2 is a negative 5. So going back to this problem right here, we had a negative 2/5 j minus 4/5 j. Well, again, I pointed out, the denominator is the same. Once you do that, then you can just add the numerators, what's on top. 2 plus 4 is 6, but we are talking about subtraction or negatives, so it's a negative 6/5 j. What do we have left now? We have 12 and a 5. What's that? 17. What's 17 minus 4? 13. So I could leave it like that and put a plus 13.
Or we could do 13.
Or you could do 13 minus 6 over 5j. Either one would work.
Could they write 1 1/5?
Yeah. Yep. Yep. All right, I want you to do 11, 12, 13, 14. Let's look at 13 for a moment. It says the dimensions of a garden are shown. It says write the expression to find the perimeter. Perimeter, that's what's around a particular object. You're measuring the lengths of each of the sides. And it may not, what you're measuring could be a rectangle someday. Or maybe it would be, something shaped like this. You're measuring the outside, each one of the lengths. So, what's the length of this one right here? It's 1/2 x minus 7. That's the length of that side. And this side is also that length. So I could just do plus 1/2 x minus 7. What's the length of this side here? X. I could do x plus, and then I could just do an x plus on the end here, since I'm kind of running out of room, plus x.
Would it be okay if you did 1/2 x minus 7, and then in parentheses next to it 2, so as if times 2, and then plus x times 2?
Well, I'll let you play with that. See if it would come out the same. So I set this up for you. Now you guys, on your own, will do the combining like terms and see what it is. Okay? All right. 15 and 16, do those. I see some like terms here. 17 we talked about earlier. All I did is I plugged in 2 for t and I rewrote those two equations. And as you guys well know, that the order matters when we're talking about subtraction or division. 2 minus 5 is not the same thing as 5 minus 2. You get two completely different answers. 18, do that one. And then 19, scratch out, and then do 20. Okay. Going to end that video.